In this video, I'll show you how my mom and I installed this copper piping system in our 1949 Spartan Manor camper trailer. In case you're new here, my name is Dan and I love to DIY things. For the past 2 years or so, my mom and I have slowly been working on fixing up this old trailer, and we can't wait to get it done, and it's been fun showing you along the way. I used to work on ships for about 10 years, and in that time I learned a lot of skills that are coming in really handy in this project. And in a way, this old trailer is like our own little ship. If you're buying your copper pipes at a typical home improvement store, you'll see that there are two varieties, type L and type M. And these just have different wall thicknesses. So type M is the thinnest, and from what I've read, typically lasts 20 to 40 years. And type L is a medium thickness, and typically can last 50 to 60 years. There's also type K with the thickest walls, which I have not seen at the hardware store, and those can supposedly last a century. I went for the type L pipes because I didn't want the M pipes to wear out after 20 to 40 years. And even if there had been a type K available, I'm not sure I would have splurged for those because there is a significant price difference between these wall thicknesses. And I almost forgot to mention that these are 1/2-inch copper pipes, which I understand are pretty standard for a house, so should be plenty for this trailer. In terms of copper fittings like T's and elbows, I didn't see any markings at the store saying whether they are type L or type M, and my research online didn't indicate anything like that either, so I just went with what they had. Of course, we could have gone with a plastic piping system like PEX, but we really wanted to stick with copper. As you can see here, we've chosen to solder our copper pipes together, and that's because we already had a torch, and it only requires some other basic things like some flux, some solder, and tools to help clean the pipes and fittings before you assemble them. Alternatively, we could have gone with press connect fittings, and those fittings actually have O-rings built into each place where they join onto a copper pipe, and you need a special tool to crimp those onto the pipes. And those tools can range from $150 for a manual one up to $2,500 for a professional grade battery operated tool. So because of that added expense for the tool and the fact that each fitting costs more as well, we decided to go with soldering the copper pipes together. And those crimping tools actually have quite a big head and need a fair amount of space to operate. And so I'm not sure they would fit in some of these tight spaces where I actually had to solder some of the joints in place. So before I show you how we put this all together, first I want to give you an overview of what exactly it is we're building. So we have one freshwater line coming in here that goes up and feeds the hot water heater. And that's because we might have a solar hot water heater preheating this water before it gets to the hot water heater, because we found out that this hot water heater can only heat the water to shower temperature if the water is already like 62 degrees Fahrenheit, which might not be the case in the winter. So we left that as an option so that we can plumb in an external water heater, whether it's a tanked water heater or a solar hot water heater, before it comes in. And our next line coming in is just the cold water that goes directly to the sink in the bathroom, goes up here, branches up and goes to the cold water inlet for the shower mixer, goes over here and goes down to the toilet, which will eventually be here, and also branches off and goes to the kitchen sink. So the hot water comes out of here, comes down here, goes over through the stud and feeds the kitchen sink, and it also goes across here, turns up and feeds the shower mixer valve. And it also continues this way and then feeds the hot water for the bathroom sink. And lastly, the water for the shower comes up here alongside the hot water heater, up through the top of our wall, and out the shower head. A major part of our water system is, of course, the instant hot water heater. So before we could plan any of the pipe work, we of course needed to get this into position. So here my mom is preparing some pieces of wood so that we can hang the hot water heater. With those two pieces of wood in, we then needed to place the little brackets that hold the hot water heater up. So we measured the centers, drilled some pilot holes, and screwed them in.
Ow! I can't stay still. Oh, my side is cramping up. The whole trailer's shit. Mom, drive the screw.
We eventually managed to get them in, and then could hang the water heater. Those wood brackets were temporary, so we could just get the pipework going, but we eventually replaced them with some metal brackets that we countersunk into the studs so that the bathroom wall could sit flat against the studs. Another big component of the water system is the shower mixer valve. The instructions for this say that the finished wall should be flush with this plastic piece on the valve, and we clearly can't do that using a 2x4 as the support. So we swapped in this thinner board and zip tied the valve to it. And later we end up removing this board because the pipework ends up supporting the valve. Here is the array of the copper fittings we'll need to do this installation. T's and 90-degree elbows were the most common fittings we used on this project, but there was this one spot here where we used a 45 in order to help get this pipe to route around this one here. We also used quite a few of these fittings, which go from the 1/2-inch copper pipe to a 3/4-inch thread. And lastly, we used 2 of these unions so that we can disconnect the hot water heater if we ever need to service it. And we're going to start off soldering this connection that goes to the hot water heater. One of the tools you'll need for copper pipework is this little pipe cutter. So just have to open it up wide enough, and then you put it right on the line, tighten it down a little bit, and then you just rotate it around. See how I made that little score? Mm-hmm. Rotate it some more. Tighten it. These are really easy to use and make really clean, straight cuts. Then after a few rounds of tightening and rotating...
That's not too bad.
Yeah, pretty easy, huh? Before we can solder any pipes together, we need to make sure all the mating surfaces are really clean and deburred. To do that, we can use this multi-purpose tool that has a wire brush for cleaning inside the pipe or fitting. And by fitting, I mean 90 or 45-degree turns or unions, and this wire-lined hole for cleaning the outside of the pipe. This hole also has a little tool at the end of it that helps deburr the inside of the pipe.
Ooh.
Nice and shiny.
Yeah.
And now you need to ream it. We also got this inner/outer reamer tool, which helps remove any burrs or edges from the inside or the outside of the pipe as well. Inside one end, 3 pieces of metal come to a point to help deburr or ream out the inside of the pipe, which I understand is quite important for clean water flow. And inside the other end, those 3 pieces of metal converge in an inverse point so that you can ream the outside of the pipe. This tool takes a bit of practice in holding the pipe just right inside either end. This white paste here is called flux, which when heated with the torch, helps draw the solder into the joint. And this is a typical lead-free solder you'll find in the plumbing aisle of your home improvement store. With the flux on the pipe, I'm trying to push it into the fitting, but finding it's actually quite hard to do. So I resort to using the hammer, which for the rest of this project, I didn't really have to do. So I'm guessing I had some kind of burr or unevenness on the pipe. Now I'm applying flux to the other end and pushing it into the fitting, and you can see how easily that went. And here's our first assembly, ready to solder. But I would actually recommend focusing on just one joint at a time, and you'll see why shortly. For the soldering, it's really handy to have a vise like this to help hold your piece in place. Of course, since this copper, you don't want to tighten the vise too much because it'll deform, but you also want it tight enough so that the piece doesn't slip around when you're trying to heat it up. For heating up the pieces, we bought this handy torch which has a built-in igniter. And now you can watch our first attempt at soldering copper together for this project. You can see here that I'm holding the torch close enough so that the brightest blue parts of that flame are hitting the copper. But later in the project, I actually found I like to hold it a bit further away, and I'll show you that later. As the piece heats up, you can see the flux starting to burn off in that wisp of smoke. I'm not exactly sure when this will be hot enough, so I keep touching the end of the solder to the joint to see when it finally melts. And there it goes. And I keep working around the piece to try and get a nice solder bead around the entire joint. On the second joint, which I thought would be easy to do at the same time, the solder is just beating off and falling to the ground, and so I call it quits on that one. With the pieces cleaned and fluxed again, I managed to get the solder to flow this time. And I think with the last one, maybe too much of the flux had burned off while I was doing the first joint, so there wasn't enough left to help draw the solder into the joint. It may also be that the outside of that joint got a little dirty and carbonized from the heat of the torch, and if it's dirty, it just really doesn't pull in any of that solder. So there's our first soldered component of the project. And if you look closely here on the inside, you can see that bright line of silver solder helping seal that joint. We made 2 of these, one for the inlet and one for the outlet of the water heater, and screwed them into place so we could figure out the layout of the pipes inside this wall. And on this one here, you can see the union actually somehow slipped off the copper pipe, so we had to heat that back up and push it back into position. With the water heater and shower mixer in position, we then had a better idea of where we needed to drill holes through the studs. I made these holes just big enough for the 1/2-inch copper pipes, but in hindsight, I wish I had made them bigger to be able to accommodate some plastic pipe holders made for holding them in studs. With the holes in the studs drilled, it was quite a satisfying and easy process to measure out different lengths of copper pipe, put on some fittings, and rough in the rest of the pipe work. This stretch of pipe work here is for the supply line to the water heater. Of course, all these joints still need to be soldered. And here's a little bit of the hot water piping roughed in. After soldering several joints, I felt like I was finally getting the hang of it, so here I want to show you that process from start to finish. I found I like to hold the torch further away from the pipes than before, and I really tried to heat it evenly. And as you can see, this takes a little bit of time, and I really like to keep it moving to heat it as evenly as possible. Once the flux begins burning off, I know I'm getting close to the right temperature. And here I'm testing that temperature by touching the solder quickly to the pipe to see if it melts. And you can see just how much smoke this puts out, so make sure to work in a well-ventilated area. Then once I see the solder start to melt when it touches the copper, I know I can start working it in around the entire joint. Once I see a solid bead of solder around the entire joint, I know I'm done. And my housemate told me a trick that you can use a cotton cloth to wipe the joint while it's still hot, and it makes a really nice clean finish. And it actually wipes away the excess solder, which I can hear hitting the floor. And that's soldering a joint from start to finish. So here's some random tips I used while soldering up these pipes. So if you're about to put a long piece of pipe like this in the vise, I'd recommend finding its center of balance. That way you can put less force on the vise while still holding the pipe securely. And to help make sure that elbows were going in at the right angle, I would sometimes put in another piece of pipe and line it up by eye. And I just realized I can use this counter to make sure this is going at right angles. Finally, I was also trying to solder as many joints as I could on the bench with the vise rather than in position in the wall. This is generally easier because you have more access to the piece, and as you'll see, sometimes when it's in the wall, access can be quite limited and you risk catching things on fire. Once I had soldered as many pieces as possible together on the bench, I'd have to install them in the wall and solder the final joints there. Fortunately, this one was quite easy because there was a lot of access around the piece and there wasn't anything too close, like electrical cables or wood, to catch on fire. For this joint right against the shell of the trailer, I had to use this small fireproof blanket. But wow, I found that that little blanket really off-gassed when it got heated up, and I actually had to leave the trailer for a while to let the air clear out. I also had to use it here, where I could find no easy way to solder a T into position. So here my mom is actually helping rotate that piece so I can heat it evenly and get the solder around the entire joint. For the shutoff valves for the kitchen, bathroom sink, and toilet, I use the shark bite valves, which slide right onto these copper pipes. As you can see, they are a 1/4 turn valve, and I really like the look of these compared to the standard ones that were available at the hardware store. So there they are installed for the kitchen sink and for the eventual location of the toilet. And it's actually gonna turn and go along this wall here, but of course I don't have the wall in, but this pipe is gonna go like this and then come in like here with the valve for the toilet water. So the toilet's gonna be right here. To run the pipe for the shower head, we of course first had to figure out where we were gonna put it. So it could be like that, which is a good height for you. And
Where do we want it now? No? Where do we think it'll be better? Because it can go higher up there, right?
Yeah.
All right. Yeah, that looks pretty cool. That looks like almost a normal height shower.
Yeah.
With the position of the shower head established, I drilled a hole through the stud for the pipe to run up along the side of the water heater and to the shower head. To approximate the height of the ceiling, I'm putting up this piece of furring strip so we can figure out how high up we can put the shower head. Then it's simply a matter of cutting pipes to length and putting them together with the right fittings. Once we had that all roughed in, it's simply a matter of soldering all the joints, which you've seen plenty of already. For the shower mixer, I was going to have to solder quite a few of the joints pretty close to the mixer itself, and so I was worried that the Teflon tape might melt with that heat. And for that reason, I decided to use this pipe dope, or more of a liquid Teflon sealant, and I really come to regret this later, and you'll see why. So don't use this, you should really use Teflon tape instead. Nonetheless, I applied the pipe dope to the inlets and outlets of the shower mixer and tightened down the copper fittings with a crescent wrench. From there, it was a matter of putting in place all the copper pipes and fittings, and then soldering them up. And once the mixer was well supported by the pipework, I was able to remove this board that we had used to support it in the meantime. And that gave a lot more room for soldering up the last joints. To make sure I didn't melt it, I also removed this plastic piece from the mixer. And since we don't have a bathtub, we've capped off this outlet for the bath spout. To secure the copper pipes within the trailer walls and also prevent the copper from touching the aluminum, which could cause galvanic corrosion and make the aluminum waste away, we found these 1/2-inch suspension clamps. These of course fit perfectly around the pipe, and the holes to the frames we had drilled out to make sure they're big enough for these clamps. Once they're in position, we simply secured them with 2 aluminum pop rivets. And these are the 1/8-inch rivets we used, and they'll be plenty strong to hold these in. To pressure test all this pipe work, I bought a cheap garden hose, cut off one end, and then pushed it over a barb fitting I had soldered to a copper pipe, and hose clamped it on. Underneath the trailer, I used a SharkBite Quick Connect elbow to connect to the cold water feed for the hot water heater. Inside the trailer, I soldered up this cap so I could test the circuit without the water heater in line. Then I connect the garden hose to the spigot, open the valve, and go check on the piping. Let's make sure there's water here. You can hear air escaping. Once I let all the air out, I tightened down the nut on that union and saw that this pipework was leak-free. So then I modified the temporary pipework underneath the trailer so I could connect both of my freshwater inlets. And what's great about these SharkBite fittings is that you can disconnect them with a simple tool and use them again. So then I turned on the hose, ran inside, and found that it was leaking right here on the input to the shower mixer. And this is why I came to regret the fact that I used pipe dope instead of Teflon tape. And while there's water in the lines, I thought I might as well test the supply line to the bathroom sink. So here's a short version of how I eventually stopped the leaks going into the shower mixer valve. First, my housemate Eddie used this torch to heat up a joint near the leak, and I used these 2 crescent wrenches to really crank down on that connection. And the other one too while we're at it. But after letting it cool and turning on the water again, it still leaked. A few days later, we heated up that same joint, backed off the connection, cleaned up the pipe dope, applied some regular white Teflon tape, tightened it back down, and tested it again. But still, it leaked. So we backed it off again, put on this gas line Teflon tape. Okay, if that's not enough, I don't know what is. Tightened it up, and finally it worked. I eventually did it on the other side as well. So according to a couple different things I've read online, this yellow PTFE tape is, quote, double density, and it may actually be required on pipes over 3/8 inch diameter, which of course these copper pipes are. But unfortunately, all the use of this torch seems to have created a leak in one of the sweated joints. To repair this leaking solder joint, I cleaned it up as best as I could with a wire brush, applied some flux around the entire joint, heated it up with the torch, and flowed some more solder into the joint. And luckily, this did the trick. To test the entire system, we of course had to install the instant hot water heater. So I applied a lot of this thicker PTFE tape on the inlet and outlet, putting in this small metal filter on the inlet, which helps prevent the heater from getting clogged up with any debris that might come through the pipes for some reason. And using a crescent wrench, I tightened down these fittings we made onto the inlet and outlets of the hot water heater. Then it's simply a matter of hanging it on its brackets and tightening up the unions. And we put unions here so it'd be easier to swap out the hot water heater should it ever fail. So that's the whole system installed. And once we put some water in the pipes, it was leaking just a bit from these unions. And I really had to crank them down hard with crescent wrenches to make them stop.
Oh, son of a gun, it's coming out of this one now. And I'm getting the exact same problem through this pipe dope.
So that's when I had to put on the Teflon tape on this side. So before we had put in the water heater, I had tried to test the flow to the shower head, and it never worked very well. But once the water heater was in, and there was water pressure on both sides of the shower mixer, it flowed really well. And I still don't understand this, but now it works, so I'm not asking any more questions. And before we close up these walls, we'll put insulation like this around all of our pipes. And there are pre-made corners like these to make your life a lot easier. And we still have some of the pipe work to do underneath the trailer where we connect the fresh water line, but there's not much work to do there. Overall, this part of the project ended up costing quite a bit more than I expected. It came in at about $620. $120 was for about 40 feet of the L-type copper pipe, about $113 for the shower mixer, $60 for the shark bite valves, and $330 spent mostly on fittings and a couple tools. In terms of time, my mom and I spent a total of about 24 hours installing these copper pipes. So I hope this video has been helpful, and in the next trailer video, we'll show you how we're installing these furring strips so we can put up insulation and walls.